If you were on the market simulation forum call last week, you'll know that we determined that we're not going to implement this solution on 7.1. We're going to continue to work on this feature, and in the meantime, that multiplier or attenuation factor is going to be set to 0 for all hours for reg up and reg down. I don't know the scheduling information for where we're going with this, when we're going to propose anything in the future, but we'll keep you posted on that. So we're working on that right now. I don't have anything further on this piece, but I will open it up for questions in case there are any.
I don't see any questions or hands raised or any questions in the chat at this time.
Thanks, Mo. All right, I'm going to continue on. We're going to go to the bidding rules. So storage or resources that are awarded ancillary services in the day-ahead market have new bidding rules. In the real time, they're required to have an energy bid to cover at least 50% of that ancillary service award in the opposite direction. What I mean by that is that if the ancillary service award is for reg up, spinning reserve, or non-spinning reserve, the real-time energy bid must be for charging. And on the other hand, if the ancillary service award is for reg down, the real-time energy bid must be for discharging. Now, when I did the original training, I had a couple of examples, which I'll go through quickly, and then I'm going to hand it over to Juan to go into more detail on some more complex examples. So, for example, if you have a storage resource, 48 megawatt hour resource with a plus or minus 12 megawatt range, if you have a reg up award of 12 megawatts in the day ahead, the scheduling coordinator would need to bid at least 6 megawatts of energy to charge in the negative direction to charge. And then if, on the other hand, if that award is for reg down, you would need to bid at least 6 megawatts of energy to discharge, meaning in the positive range. That's example 1. Example 2, if that resource had 8 megawatts of reg up awarded and 8 megawatts of reg down awarded, then in real time they need to bid the remaining 4 megawatts of discharging and charging range as energy. Now, what I noted at the bottom here is that the final proposal, if you're interested in it, there is a link to that final proposal to get more information on this. I'm going to hand it over to Juan, and he's actually going to take a look at some of the verbiage in that final proposal and then talk about some additional examples. So Juan, if you can unmute yourself, we can have you take over here.
Good morning, this is Juan Alvarez, PhD. So I will be talking about a little bit some examples on what was written in the final proposal dated October 27, 2022. And then with this, we will be able to explain how the software is working and also why these constraints were implemented, referencing this final proposal policy paper. So these are screenshots taken from the final proposal, and the reference there is page 12 and page 13, and we'll be talking about it. And the first part talks about what were the changes between the original proposal and the final proposal. Basically, we relaxed the requirement of the 50% energy bid in the opposite direction of the AES award for day ahead, and we only kept it for real time. So currently, real time is the only one who expects an energy bid in the opposite direction of the AES award from day ahead. And in page 13, and this is kind of the key part of this final proposal, we have the statement that the day-ahead market will not allow or award ancillary services in the day ahead that cannot accommodate the required energy bids in real-time market. So basically what this means is that the day-ahead market will not award any AS that cannot accommodate that 50% requirement in the opposite direction, and real-time cannot use that full bid to be able to dispatch the resource. And of course, this other portion comes from the examples that are in the final proposal and that we will analyze shortly. So let's go to the next slide, please. So what we have here is an example of a plus minus 12 megawatt storage resource. And there's one example in which you have a 12 megawatt regulation up that will require a bid on the opposite direction of 0 to 6 megawatts to charge. So that's one example. Then the other example that we have here is an 8 megawatt reg up and 8 megawatt reg down award of day ahead from day ahead, and then that will require 4 megawatt energy bid to discharge and a negative 4 megawatt bid to charge. And this is also allowed in the market. And the last example is why 9 megawatt regulation up and 9 megawatt regulation down cannot be awarded because of this constraint that we have, that the day-ahead market will not award anything that cannot fit the 50% of the energy bid in the opposite direction. And then we'll show some examples here with visually we can see why this is not allowed. So basically what we take from these examples and the language in the policy is that the concept is that the energy bid in the opposite direction, along with the AS awards, they have to fit between the upper and lower capacity range, and they have to be dispatchable for the whole range. So let's go to the next slide, please, and we'll see some graphics that will help us to understand this. So this is what we have in the form of equations, and we're numbering here 1 and 2, and these are the ones that we are going to be focusing on today. And equations 3 and 4 are the ones that enforce the requirement inside market for the energy bid in the opposite direction of the 50%, that is that coverage factor, that CF that you see here. So equations 1 and 2 exist in IFM, in the day-ahead market, and also exist in the real-time market. Equations 3 and 4, that is the requirement of the energy bid, exist only in the real-time market. And equations 1 and 2 are the ones that are responsible for ensuring that that capacity is reserved, so we can dispatch the resource for the whole range of the energy bid in the opposite direction in real time. So equations 1 and 2 are the ones that are responsible for that. And here we have the coverage factor and the lower capacity limit and upper capacity limit. So yeah, I guess we can go to the next slide, please. Okay, so in here we have the first example, and we have the regulation up award of 12, no regulation down award, and an energy bid in the range from 0 to minus 6. And here I have equations 1 and 2 with this numerical example, and we can see how these two constraints allow this type of award in the day-ahead market. And it is important to notice that if you were to award in real time this resource -6, like a charging of 6 megawatts, in real time, you can see that your regulation up sits in the upper capacity limit. So I'm just trying to get my pointer here. Okay, so I guess you can see an arrow. So you can see here that if I were to award the resource here at -6, then the regulation up award fits in the upper capacity limit. Same thing, if I were to award this resource at 0, the regulation up award also fits in the upper capacity limit. So this is what these constraints are enforcing and ensuring that whatever AS award that we have, once we submit the energy bid in the opposite direction, they will fit between the upper capacity limit and the lower capacity limit, and we will have the whole range of the energy bid to dispatch the resource in real time. So, okay, and somebody saying that I cannot see my arrow. I'll try it next. Okay, anyway, let's go to the next slide, please. Can we go to the next slide?
Everyone, I'm trying to make this go to the next slide. Hold on just a second.
Sure, thanks.
Hold on. Sorry. I'm going to stop the presentation for just a second. There we go. Sorry.
All right. Thank you very much. So here we have the other example in which we have regulation up and regulation down award of for 8 megawatt and an energy bid that has the range for +4 to -4. Then again, here we have equations 1 and 2 where I have substituted the numerical values, and we see that these two constraints hold. And the point here is, again, that when you were to award an energy of -4, you can see that your regulation down award fits in the lower capacity limit, and also your regulation up award would also fit in the upper capacity limit. If you were to award at 0, your regulation down award will also fit, because we'll go from 0 to 8, and it fits in the lower capacity limit, and the regulation up also fits because it will go from 0 to 8 in the upper capacity limit. A similar situation would be if we award, say, at +4, your regulation up fits between the 4 plus 8, it fits in the upper capacity limit of 12. And of course, if we were to award again at 4, then your regulation award would go, reg down award also fits going down to -4. So again, we can see that we have the whole range to dispatch from +4 to -4. And we have the whole range to dispatch the battery between 4 and -4, and still the regulation up and regulation down awards fit in the upper and lower capacity limit. Okay, can we go then to the next slide? And this one shows the other example of why we cannot award regulation up and regulation down of 9, because in this case, it would require an energy bid of 4.5 to -4.5. That would be the 50% of the 9 reg up and reg down award in the negative direction. So if we were to schedule a resource at 0, yes, the regulation up fits of 9 megawatt from 0 to 9, and it's within the upper capacity limit, and also the regulation down award would fit. The problem is, if we were to award at 4.5, then the regulation up award doesn't fit, as you can see in the red marker here. So it wouldn't fit if we award at 4.5, then we cannot go and deploy the regulation up of 9 because it's beyond the upper capacity limit. Similar situation is if we were to award at negative 4.5, we cannot deploy the regulation down award because it will go beyond the lower capacity limit. So as we can see with these two constraints do not hold, preventing the real-time, it will prevent the day-ahead market to give us this award for real-time because then it wouldn't accommodate the energy bid along with the AS awards. And let's just look at one last example.
Oops.
This one. This next example explains why we wouldn't allow a regulation up award of 16 with a regulation down of 0 and an energy bid between 8 and negative 8. Because say if you regulation up, then your requirement in the opposite side to charge would be from 0 to negative 8. So again, the way that we can see this is, of course, if we were to have the energy bid at negative 8 or the award at negative 8, we can see that, yeah, the regulation up award does fit and it doesn't reach the upper capacity limit. If say we award at negative 8. If we were to award at negative 4, yes, it also, the regulation up award of 16 also fits in the upper capacity limit. But then if we were to award anywhere from negative 4 to 0, then we don't have, or we are not able to accommodate the regulation up award of 16 because it's beyond the upper capacity limit. So then from all these examples, what you can see is that we need to accommodate the full range of the energy bid along with the regulation, or in this case, the AES awards that come from day ahead. And to ensure this, that's why we have these two constraints in the real time market and in the day ahead market. So day ahead market will prevent giving any AES award that cannot be fulfilled in real time once we have the 50% requirement of the energy bid in the opposite direction. So that's all I have about these examples, Cynthia, so I'll hand it over to you.
All right. All right. I see that, Mike, did you have a question?
I think so, Cynthia. Yeah, it's Mike McGuffin from CES. And Juan, I won't rehash this. It seems like we've been debating this for several months now, but I still don't quite understand how the math works with the example that you just put up, given the unit can, in fact, offer 50% of its awarded capacity into the real-time market, sufficiently meeting the 50% criteria. I know you guys have made that clear that that's not your policy, but I'm still not clear on why that is. My question more is what is happening in the real-time market, because it appears that the ISO is still extending and forcing or extending resources to submit any unencumbered capacity in the real-time market. So to the full regulation range. So when I submit a bid, if I've got 1 megawatt awarded regulation on a plus or minus 10 megawatt resource, if I have a 1 megawatt award in day ahead and I go to submit 10 meg the remaining 9 of that product, Cyber will extend my bid to the full regulation range of 20 megawatts, and it'll do that on both ends. So is that just an oversight in the cyber rules, or is not consistent with the policy, or is that something different in the real time where you actually are able, the ISO is able to redispatch a resource to ensure, basically be able to dispatch a resource to take advantage of the full regulation range?
So I'm not the subject matter expert for cyber. However, I can speak to what the software is doing. Even if the software was going to have the energy bit for the full range, since these constraints are inside the market applications, we will not award anything. Like, we will only award the energy portion that can fit the day-ahead award. Because
okay, so real time is consistent with how you've explained day ahead working then.
Exactly, yeah, and that's why we have these two sets of constraints. The one set, it's in real time and day ahead, and this is the one that reserved that capacity of the 50% of the AS award. So that's why those two sets of constraints are in real time and in day ahead. So then when real time comes, that portion will still be reserved to cover that. And then of course you can submit an energy bid that is more than that, of course. And the real time market will only award an energy as long as it, and even more, of course, but as long as the day ahead AS can fit in real time when we use that bid in real time.
Okay. Yeah, I've just been curious if it was going to be consistent, because that, I mean, it seems like that might have been an oversight in planning. It would seem that you wouldn't extend the bid to the full regulation range in real time if it's not possible to be used in any scenario. So maybe I can bring this up on the sim call as well, but that's seems inconsistent.
Yeah, that would be best from somebody from cyber to be able to explain that. But at least from market side, we would be covered, and we do have consistency between the day ahead and the real time market.
Okay, thank you.
Yep, thank you.
Thanks, Mike. I see Alva, you have a question. Do you want to unmute yourself?
Sure, this is Alva Svoboda from PG&E. I actually wanted to go back to the example one, because I thought in our previous discussions, you made it, I think there's something that would probably explain, in my mind, it explained and made reasonable the, if you can go back to that slide, I don't know if you can see it, but the case of the 16, what you explained, and which I think is correct, is that when you have an award of -4 that's supporting the 16 megawatts of reg up, that looks fine, except for the problem with storage, which is that the dispatch of the battery can be affected by the state of charge. So CAISO can essentially be forced in real time to go from the -4 to some level above -4, because it's out of upward capability to charge any further. When that happens, the battery is not capable of supporting its 16 megawatt award. And so to me, that's a very reasonable rationale for why the CAISO in the day-ahead market has to not allow an award of above 12, because any charging schedule that's awarded day-ahead may have to be reversed just because of the fact that they have to dispatch based on state of charge. The corollary of that, however, is that if you look at this same situation in real time, this situation doesn't exist in real time. If you have an award of 12, the CAISO for a given interval can dispatch 16 megawatts of reg up, because it knows at that point it's doing this, it's doing the two things at the same time. It's doing the energy award and the reg award at the same time, in effect. And so there is no reason that you shouldn't be able to award more in real time. And so to Mike's other question, my opinion, which is, and I know this is not going to be the implementation on 7.1, but my opinion is that full, 24 megawatts here in this case, or whatever Mike was citing as the full range, that should be accessible to CAISO. CAISO can get more regulation, and participants can get more money potentially without this being an issue in real time. So this is just in a response to Mike's comment, but I do think you explained why this is a correct assessment for real time. So thank you.
Yeah, thank you, Alva.
Hey, this is Steve Murtaugh from California ISO, the policy group. I wanted to back up and just ask Mike a follow-up question. Mike McGuffin, are you still on?
Gabe, welcome back.
So are you just concerned about, the potential ability for a storage resource to bid, a fraction of its regulation up, or was your concern something different than that?
Well, I just think mathematically it works out where a resource should be able to submit up to 133% of its nameplate capacity, and then be able to support that in the real time with a real-time energy bid.
Yeah. Okay.
Yeah, but then in the end, and I know that ship has sailed. You guys made your point in the sim calls. I was just wondering why, if it was going to be different in the real time, because the bids are being automatically extended to the full reg range, as if you you would be able to redispatch and do that very scenario in real time.
Yeah, and it just I mean, the reason I ask is because we have had some internal conversations about potentially partitioning regulation bids into, multi-segment and potentially allowing resources to not bid the full capacity for regulation up or regulation down products. So if you've got strong desires or urges to change those rules, we could maybe chat offline about them.
Yeah, I mean, I really don't have a horse in the race. I just trying to understand how to actually implement this on July 1st. So just wanted to be able to explain that to my team and our clients.
All right. Thanks for the follow-up. I appreciate it.
Yep.
Hey, does anyone else have any questions for Juan or Gabe? I don't see anything in the chat, and no hands are raised, so I think I will continue on here. There will be another opportunity to ask questions and at the end, so if you think of anything, it will be, you'll have a chance to do that. There was just one more piece that I wanted to add on regarding the bidding rules. An energy self-schedule is not considered a bid. You need to put in an economic bid in real time for that energy. If your energy bid doesn't equal at least 50% of the AS award, the bid is going to be extended. And if you don't submit a bid, if you have an AS award, a bid will be inserted at the default energy bid price. All right. So I think we probably went through all the questions on this already. Again, we'll come back to it at the end. Just have a couple more slides. So we're going to talk about the default energy bid changes for energy storage enhancements track 1. So the issue was that there were instances in the day-ahead market when storage default energy bids caused unanticipated results. The ISO observed cases where scheduling coordinators submit day-ahead bids at a consistent price throughout the day, but the resource nonetheless receive a day-ahead schedule to discharge during the late afternoon hours and not during the highest price hours in the evening. And this occurred because the bids were higher than the debs, and market power mitigation triggered during earlier hours of the day and not the later hours of the day. So this is what it looks like today. On 7/1, we're going to change it to align with what the real-time DEB that we use is. So you can see here that the solution was to include the opportunity costs in the day-ahead storage DEB formula. So it more mirrors what we are already doing in real time. So now it's going to be the maximum of the opportunity cost and the maximum of the energy cost in zero, plus the variable energy costs, variable costs, times that 10% adder, and that will give you the day-ahead storage default energy bid. And for those of you who are interested in the formulas, I did add them at the bottom. Are there any questions about the storage default energy bid?
As a reminder, if you'd like to ask your question, you can use the raise hand icon to ask your question, or you can add your question in the chat. Cindy, I don't see any hand raises or any questions in the chat at this time.
Thanks, Mo. That pretty much concludes the presentation. The wrap up essentially is, keep continuing to attend today's market sim call. And as always, plug into our RUG, release unit commitment, release user group calls, and our TUG calls, our settlement user group calls, our technical user group calls, to keep up to date on the most current information. If you have questions, we'll open it up in just a second, but I want to thank you for participating. If you have questions about the training, please send an email to customerreadiness@caiso.com. If you have questions about the policy or anything else related to Energy Storage Enhancements Track 1, we want you to submit a city ticket. If you have access to city, you can access it in the market participant portal. Otherwise, if you don't, if you go to the ISO website and you go to contact us and submit your question, it will become a city ticket, and then it will go directly to the right people who need to look at it and get back to you. So I will open it up for final questions. I am not seeing any questions in the chat or no hands raised. So I want to thank you all for participating. We will be posting this information on our website in all the usual places. So you want to take a look for that a little bit later. I will also post the recording, and I think I cut off the first part of the recording. Thank you, Mo, for turning that on for me. So we'll get most of it recorded, and we'll post that. Again, thank you very much, and have a good rest of your day.